Hello, this is Ms. Swantek, and we're going to be taking a look at line graphs today, which is lesson 7.6. To get us started today, I'm going to give you a little joke or riddle. It's a discussion between a teacher and a student. So the teacher says, "Are you good at math?" The student says, "Yes and no." The teacher's like, "What can you possibly mean? It's either a yes or a no." And the student goes, "Yes, I'm no good at math. No good." All right, but I know that all of you are wonderful mathematicians and you're enjoying the video lessons and you are going to do a great job today with line graphs. Getting our brains starting, here we go. We're going to take a look at some math reflexes, adding fractions. Okay, if you want to go ahead and pause to try to answer these questions, otherwise I'm going to go ahead and discuss them. Whenever we are adding fractions, we need to make sure that we have a common denominator. In this case, we have 12 and 12, so that is in common. So the denominator is going to stay the same. Then you are going to add your numerators, since we're doing addition here. So 3 plus 3, which is 6. We've been working on simplifying fractions as well, which means making it smaller. A lot of you are realizing, hey, 6/12, that's the same as having 1/2. We went from 6 to 1 by dividing by 6. 12 divided by 6 is 2. Another example, 36 ninths subtracting 18 ninths. We have a common denominator, so the 9 is going to stay the same. And now we're going to head and subtract 36 minus 18, subtracting our numerators, which we would get 18. We should recognize that this is a top-heavy number or an improper fraction, which tells us that there's going to be a whole number hidden in there. So you have to ask yourself, how many times does 9 go into 18? Without going over, and we should have gotten the answer of 2. 9 times 2 is 18, so there are 0 ninths left over, or just the answer of 2. We have not taken a whole lot of a look at this, but we can be adding 3 fractions together. You just need to make sure that all of the denominators are equal, or they have an equivalent denominator. In this case, we already have 4s, so 4 is going to be our denominator. And we're going to add 14 plus 6, which is 20, plus 5, which is 25/4. Once again, we should recognize that it is top-heavy, or it's an improper fraction, so there is a hidden whole number in there. So how many times does 4 go into 25 without going over? Well, that's going to give us a whole number of 5. Denominator stays the same. 4 times 5 is 20. We need to get to 25, which is 5/4. So some of you are saying, hey, right there, once again, we have an improper fraction. So we know that it goes into it more than 5 times. So what's a number higher than 5? 6. Denominator of 4. 6 times 4 is 24. When we got to get to 25, so 1 is our numerator, so 6 and 1/4. Some more math reflexes here. Now all of a sudden we may have different or unalike denominators. So we first need to figure out in 6/5 and 4 and 40ths, we need to find a common denominator between the two numbers. Some of you are realizing that 5 goes into 40 because 5, 10 is all multiples of 5 are either going to end in a 5 or in a 0. So now we need to make 6/5 equivalent to 40ths. Remember, whatever you do to your denominator, you need to do to your numerator. So how did we go from 5 to 40? We multiplied it by 8. We need to do that to our numerator as well, which is 48. Now we can replace this fraction because we made it equivalent, 48/40ths. We have the same denominator, and now 48 minus 4 is 44. You should see that there is a whole number in there because our denominator is smaller than our numerator. How many times does 40 go into 44 without going over? Well, it goes in there one time. Denominator of 40 is going to stay the same. 1 times 40 is 40. We need to get to 44. So 4 40ths, which both are even, so that means we can reduce it down. So 40 divided by 2 is going to be 20, and 4 divided by 2 is 2. Some of you are saying, hey, they're both even. That means we can reduce it down again. Divided by 2, 2 divided by 2 is 1. 20 divided by 2 is 10. Okay, so 48 40ths, 1 and 4 40ths, 1 and 2 20ths, and 1 and 1/10 are all going to be the same answer. They're equivalent, but 1 and 1/10 is the most reduced fraction. Looking at 12 thirds and 3/9, we need to have a common denominator. Some of you remember skip counting, 3, 6, 9, 12, and then going 9, 18, and you realize that, hey, you have both 9 in common. So we'll give this a little bit of room here. So we're going to get both into ninths. Well, 3/9 is already done, so now we need to make 12 thirds into ninths. How do we go from 3 to 9? We multiplied it by 3. Need to do it to the numerator, which is 36. Replacing 12 thirds with 36 ninths. Denominator is going to stay the same. Add 36 plus 3, which is 39. And now we need to go ahead and reduce our fraction or make it smaller. Some of you are seeing that it is a top-heavy number, which is also a part of simplifying. So how many times does 9 go into 39 without going over? If you said 4, you are correct. 9 stays as our denominator. 9 times 4 is 36. We need to get to 39. So 4 and 3/9, which is equal to 4 and 1/3. 3 divided by 3 is 1. 9 divided by 3 is 3. All right, now we're going to go ahead and get started with our lesson of the day, which is taking a look at line graphs, which many of you have mastered this skill. But we're going to take a look at our math message, and we're going to say and look at what are 2 different methods that you can use to organize collected data. Some of you are saying, bar graphs, I can represent my data with bar graphs. I can represent it with circle graphs, and I can represent it with line graphs. But which way is going to be the best way to represent data? That's going to have to be what data you're actually looking at to see if it's better to be looking in a pie and looking in percents. Then we're going to want to look at it as a circle graph. If we want to look at trends or how things go from one point to another point, maybe it's going to be a line graph. Bar graphs can be a great way to show us how many people like certain things or what the temperature, how the temperature increased or decreased over time. Temperature is also a great way to do line graphs as well because it has that trend. Using a Venn diagram is a great way to show how things are similar and how they are different, or comparing and contrasting. In this Venn diagram, I'm really looking at bar and line graphs. Bar graphs often are using bars to represent their data. However, line graphs compare trends. You've heard me talk about trends already. A trend is how something has changed over time. They both, however, are going to represent data. They're both going to have a title, and they're both going to have labels as well. And they both are going to have a horizontal and a vertical axis. So many times you see this type of a setup for graphs. Taking a look at this graph, we're going to go ahead and try to figure out what information is represented. It says, did more students bike to school in March or in June? Taking a look at some of the things about this line graph. We have a title, so it tells us students who bike to school. We know that we have some labels of months, and we're talking about students in numbers. Here's an example of how they're showing trends, how things change over time. Well, in March, we can see that about 80 kids biked to school. However, in April, there was only 60. In May, 80. You always are going to go up with your data and across. It's also very important to see what are the increments on the side. We're going from 0, 10, 20, 30, 40, so we have increments of 10. So now we have our information. Now we can actually go ahead and answer the question, did more students bike to school in March or June? March, we had 80. June, we had 90. So the correct answer would be June. In another graph, we're going to take a look and see, is the information presented correctly? Taking a look again, we're talking about employees here and years. So up here it tells us that employees with health care benefits. The data says in the year 2000, 50 employees had benefits. So in the year 2000 in graph A, do they have 50 people? They do. In the year 2000, do they have 50? In this second graph, they do not. It only goes up to 25. So which graph is correctly representing the data? You should have said graph A. Taking a look at another example of some lines and trends. This one is emails that a certain individual received. You can see that our labels are days, Monday through Sunday, and how many emails they received. The question we're trying to answer is how many emails did they receive on Monday and Tuesday? So really, we don't need to look at all of this information over here because we only need to know Monday and Tuesday. And the question says, how much did they receive? They want to know all together. When we're talking about all together, that means we're going to have to add our data together. So on Monday we had 2, and Tuesday we had 9. 2 plus 9 is 11 emails. The last graph that we're going to take a look at today that shows some trends over time is prices of barrel of oil. And this is real data. It shows how over time it has increasingly gone up. Believe it or not, back in the 90s, gas only cost about 90 cents, and now we're paying between $2.50 to $3.50, depending on the prices of the barrel of oil and what are some situations that are occurring. You can see that we're talking about years, and then we're talking about the price for a barrel of oil. It wants to know which year was the graph, on the graph, was the oil the most expensive. Well, this is $0, this is 55, so the number that is the highest is going to be the most expensive. So the year 2005, it is the most expensive at $50. You have received all the information you need to be successful with line graphs. Good luck tomorrow as you attempt your math journal pages.